name is Caleb Cage. I'm going to just provide a really quick introduction of Mike Fisher, our moderator here. Mike has been is the administrator of the Division of Minerals and has been since 2016. He spent 16 years working as an exploration geologist for FMC Gold and its successor, Meridian Gold, with 6 years of manager of their Rossi project. He's here today. He's going to provide a brief presentation and just tell me when to click slides and introduce our panelists as well. So go ahead, Mike.
All right. Thanks, Caleb. Thanks for attending this talk. Just quick little background on what the Division of Minerals is. We're a very small state agency. We do not permit mining in the state, but we are kind of the information hub for mining and exploration and to assist getting information out to the public. But one thing we do regulate is fluid minerals. So we are the fluid minerals regulator for the state of Nevada. That means oil, gas, geothermal. We permit that out of our shop, whether it's on private land or public land. And then we also permit dissolved mineral resource exploration. So think of lithium brine. So any lithium brine exploration comes through our shop as well. So it's a good venue for us to talk about what we do, but also give you guys an introduction to what's so special about Nevada. So go ahead, Caleb. So what are the clean energy minerals? Well, we've got some loud ones that you hear an awful lot about, and you got a bunch of quiet ones that are just as necessary, but you don't hear a whole lot about. Unless you're in the exploration community, you may not even recognize these names. But a lot of these occur and are currently mined in Nevada. So it's very important that we understand what they are, what they do, where they're formed, and how you might extract them. Next. So how are these minerals used, right? So here's the different clean energy technologies, and then how some of the minerals get used in each of those, and whether they're low consumption, moderate, or high consumption. So how much do we need of these minerals, right? And you can see all across the technology spectrum, we require a lot of key minerals, right? These are the crucial minerals that we need for clean energy technology. And we have copper, we have nickel, we have lithium, we do have some rare earth occurrence here, we have zinc, we do not have aluminum, we have a little bit of platinum, but a lot of these do occur in the western US, and we'd like to see more of that extraction occurring in the western US instead of overseas, coming back and forth across the ocean. Next. How much are we going to need for the different types of technology? So there's this really good report, if you haven't seen it, International Energy Association, IEA, put this out last year. Really good in-depth report on what minerals are needed for the different types of technologies, and then forecasting how far out, what the demand is going to be, and why we need these. So you can see the amount of material that's needed just to generate a megawatt of these different minerals. Quite impactful. And this is something that a lot of people don't think about. They just think that it's clean, so it means it must be something that comes from the sun or the wind. But something has to transfer that energy to electricity, and that's where these minerals come in to play. Next. We've got an unprecedented demand for these key minerals, and you can see here kind of by the different scenarios. So the SDS is a sustainable development scenario. So that's kind of a moderate anticipation that we're going to need for the clean energies. And then there's that goal that's out there for net zero by 2050. Well, in order to do that, you can see the amount of growth that's needed for these key minerals. Look at lithium, 42 times more than we have that we're using now. That demand's going to 42 times. That's crazy. But where is all this going to come from, right? So all these other minerals that are necessary, that we need to have these technologies. Next. So where are these currently produced? So this is really important. If you look at, so look on the right-hand side and you see where US is, and that kind of blue. But then look over on the extraction side. You only see that blue on the mineral side at rare earths. But then you go across over to where it's processed, none of it's being processed in the US. The only thing that's occurring over here is oil refining and LNG export. So none of the crucial minerals needed for these technologies are currently being processed in the US. And right now, we're still reliant on all these other countries to produce these key minerals. Next. So what is Nevada's role in this? Well, if you didn't know, the lithium brine deposit model originated here in Nevada. Then, in 1966, it was essentially exported, both the deposit, its occurrence, and how you extract it through solar evaporation. That process for increasing the lithium was exported down to South America, where now we're getting 78% of our lithium resource for the global supply. The one deposit or the one mine since '66, that produces about 1% of the global need of lithium. So Nevada is well endowed with a long history of big mineral resource, supportive infrastructure. We lead the nation in hard rock mining and how to regulate it. And what we're seeing also is this consideration for environmental, social, and governance consideration. So you hear this a lot, ESG. And what that's doing is it's moving a lot of these global companies that recognize ESG to these more mature regulatory environments. So Canada, Australia, the US, Northern Europe, and away from some that don't look good for ESG, right? And so that's good for the US. Nevada, we consistently rank as in the top 5 global jurisdictions for investment attractiveness for mining. That's by the Fraser Institute. And then the critical minerals, so there's 50 critical minerals that were outlined by the USGS in 2022. 33 of those occur in Nevada. Doesn't mean 33 could be mined here. There's a big difference there. But they occur here. So that's why there's a lot of exploration interest in Nevada. And interesting, we rank number 1 on the count of critical mineral occurrences per acre. So here's why Nevada is playing this big role. Next. So yeah, Nevada, the lithium state. We are not the only lithium producing state in the country anymore. So since 2020, U.S. Magnesium has been producing lithium at their magnesium mine at Great Salt Lake. So they are producing some now, but we have the only current primary lithium mine in the U.S. And if you look at the price chart on the left, that top left, you can see since 18, pretty flat, and then last year, that huge spike. It got over to $70,000 a ton for lithium carbonate equivalent. I saw a forecast up in Vancouver last week about the forecast for lithium price, because everybody's concerned, are we going to see it fall off? No, they really expect it to stay north of $40,000 for several years because the demand is there, right? So the demand drives the price. The price also drives exploration interest. That demand for lithium chemicals is going to increase quite a bit. So that's something to keep an eye on as well. But we have the Thacker Pass project. Tim's going to speak about that. The Salton Sea, you hear about that quite a bit as well. Very high salt concentrations of the geothermal brines down there. The challenge has always been, how do you selectively get the lithium out without extremely high costs, right? So expect that we'll probably see some technologies come forward that's going to help out on this as well. Kings Mountain is a pegmatite deposit. Lithium can occur in spodumene and pegmatites, and that's a very old historic one. That's where Albemarle got its start. They're going to be remining that here soon. Next. So lithium exploration. So this kind of comes back to my shop and what we do with the permitting for lithium brine exploration, and we get these calls all the time. How many mining claims are there for lithium? Well, it's kind of a little bit of a guess. There is some science behind it, but right now there's more than 44 different companies in various stages of exploration for lithium. About 35,000 mining claims, but that's only about 13% of all the mining claims in Nevada, okay? More than 50% of all the mining claims in the US are in Nevada. So this is where everybody's looking. 28 current authorized or pending lithium notices. That's the very first exploration part. 10 in 2022 alone. That compares to almost 10 times more for silver and gold. Okay, we're still very much silver and gold dominated. 2 exploration and 8 mining plans for lithium compared to 134 for gold and silver. For placer claims, which are generally used for locating and reserving your ability to extract lithium brine, there's over 18,000 placer claims. 30 different companies are involved through various agreements, handshakes, joint ventures, whatever you want to call it. In Clayton Valley alone, it gets very messy down there. 26 lithium and sediment projects, those are considered to be done by open pit. 35 lithium brine projects. The big thing about this one is I really do not expect to see another Silver Peak solar evaporation process occurring in Nevada. The water consumption is too high, the cost for water is too high, the environmental footprint is very high. Everybody is waiting for some enhancements with direct lithium extraction technology. SLB, formerly Schlumberger, has a pilot plant that they are constructing right now. Hopefully this summer we'll get some news out of them as to whether they're able to produce lithium carbonate from the brine in Clayton Valley. So my shop, since 2017, we've issued 47 notices for lithium brine, 17 well permits, but most of those came last year. Again, when that price goes up, we get a lot of investment money that's coming into the state to explore for lithium. And then you can see some of the distribution there by townships in the state. Obviously a lot concentrated in Esmeralda County where Silver Peak is located. So I want to just provide this as kind of an overview of why Nevada, why is it so special, why are people looking here, why is this a big deal? And then we've got some subject matter experts here that I'm going to introduce, and we'll just go in this order. Okay.
I'm going to speak next.
Okay, great. So I want to introduce Debbie Struhsacker. Debbie is a hard rock mining policy expert with over 30 years of hands-on expertise with the environmental and public land laws and regulations pertaining to mineral exploration and mine development. Ms. Struhsacker provides environmental permitting and government relations consulting services to mineral exploration and mining clients. She is a Pi Beta Kappa graduate of Wellesley College, where she majored in both geology and French. She also has a Master of Science degree in geology from the University of Montana. So, thank you.
Thank you, Mike, and thank you for your great presentation and overview. I'm going to speak a little bit about the regulatory framework that governs the mineral exploration and development work that we do here in Nevada. I'll give you a minute to get that all teed up here. It's great to see so many people at this conference, and you know, it really speaks to the excitement that we have in this state for developing. Am I in your way?
I'm trying to see if I can,
If you need to click on that little guy right there.
it's not showing up on my screen.
Technical difficulties, sorry. If you just bring up the whole presentation on your screen,
There we
and
go.
then there you go, and then yeah, perfect. Thank you. Okay, and you can move on to the next slide then. So before we talk about what the regulatory requirements are for mineral exploration and development, you got to know what kind of land you're on. So I'm going to spend a little bit of time talking about land status here in Nevada because it's kind of unique to this state and it really drives what the permitting requirements are. So roughly 85% of Nevada is federal land. We have about 13% private land in this state. It's a rather unusual situation. I think Alaska is the only other state that has more federal land than Nevada. So this pie chart, which is from Mike's shop, the Nevada Division of Minerals, shows that the bulk of the land here is managed by the U.S. Bureau of Land Management. And that's this big blue slice of the pie. The other agency that is of importance to mineral exploration and development, federal agency, is the Forest Service. And the Forest Service has about 8% of the land here. They manage about 8%. The rest is divided up into other federal agencies like the National Park Service, Fish and Wildlife Service, and then here in Nevada, we also have a large footprint of the Department of Defense and Department of Energy lands. So again, that leaves us, and those are off limits to mining because you can't have a bombing range and a mine in the same place. So the next slide is going to show a map of where these lands are located. And I know this is kind of a little bit of busy map, but it's complicated land status here in Nevada. And again, many thanks to the Division of Nevada Division of Minerals for putting together this map for me on kind of short notice. But it's a tremendous resource down in Mike's shop as far as understanding what the lands and the land status is here in Nevada and where the claims are located, and of course the geology as well. But what you see here, just like that pie chart, is a sea of blue. And that sea of blue is BLM administered lands. So then that's roughly that 66% of the lands here in Nevada. The Forest Service are these mountain ranges here. So those are national forest lands. So in a broad sense, mining, a lot of mining takes place in Nevada on either the blue or the green lands, where you can locate a mining claim under the U.S. mining law. But I don't know if you can see it from where you're seated, but there are all these areas, hazard areas, that are actually off limits to mining. So even though those are public lands, you cannot locate a mining claim there, or if you can locate a mining claim there, there are many, many operating restrictions that make them very unattractive areas to look for minerals. Other big kind of takeaways here is the private lands, which are this kind of salmon colored. As you would expect, they are surrounding our metropolitan areas. So the Las Vegas area and the Reno, Carson City corridor here in northern Nevada. And then you see that kind of snaking through across the I-80 corridor. That's the Nevada checkerboard, which is comprised of alternating sections, 1 mile square sections of public land and private land. You'll see a little, islands of private land here in the sea of blue BLM, but they're sparsely distributed, again, along some of the rural communities that we have, and some of those represent patented claims. But by and large, if you are exploring for minerals here in Nevada, you are dealing with either the U.S. Bureau of Land Management or the Forest Service, the blue areas and the green areas. If you're lucky, you might be operating on private land if you have you own the private land, or you have a lessor, a private land lessor who welcomes your activities. But by and large, most mining activity for any commodity here, gold, silver, lithium, copper, involves some measure of public lands. Okay, so next one. So mineral exploration and development here are highly regulated by sophisticated state and federal regulatory agencies. The principal Nevada state regulatory agencies are the Nevada Division of Environmental Protection, and there are 2 bureaus within that division that are our principal regulators. There's the Bureau of Mining Regulation and Reclamation and the Bureau of Air Pollution Control. And I have a little parenthetical there saying, except if your operation might be in Clark County or Washoe County, if you need an air quality permit, you deal with the counties there rather than NDEP. Nevada Division of Water Resources, a hugely important state agency for mineral exploration, because if you don't have water, you can't explore for minerals, and certainly you cannot develop a mine. And then the Nevada Department of Wildlife plays a big role. On the federal side, our principal federal regulatory agencies are the Bureau of Land Management, so again, the land that was shown in blue on the map that I just showed, the U.S. Forest Service, the land that was shown in green, Fish and Wildlife Service, the U.S. EPA, sometimes the U.S. Army Corps of Engineers will be involved. If you have wetlands or jurisdictional waters, then you need a 404 permit from the Army Corps. And of course, safety is a very, very important component of everything we do in the mining industry. So both state and federal regulations for mine safety, and we've got the U.S. Mine Safety and Health Administration. So in Nevada, we have a very mature and a very knowledgeable and a very effective regulatory regime affecting mineral exploration and mine development that is essentially a partnership between the state and federal agencies. And that partnership is largely governed by a memorandum of understanding between NDEP, again, that's the Nevada Division of Environmental Protection, BLM, and the Forest Service. And this MOU has been around for a long time. I mean, it's over 20 years old. It's been updated a couple of times. But it governs how the federal land management agencies, the BLM and the Forest Service, work together and in pretty seamless coordination with NDEP. And under that MOU, the three agencies co-manage the financial assurance program for mining. So any kind of mineral exploration or mineral development work on either state or either private or federal lands requires a reclamation bond. And reclamation bonds are co-managed by these three agencies. And the reclamation rules here are relatively, I don't want to call them new, but they went into effect in 1989. So, within the lifetime of many of us sitting in this room, certainly. And since 1989, that program has grown to a $3.3 billion program of financial assurance that is in place to ensure that any kind of mineral exploration and development on Nevada lands, regardless of land status, will be fully reclaimed when those activities are completed. Part of the regulatory program for that financial assurance is driven by some specialized software that the Nevada Division of Environmental Protection developed called the Nevada Standardized Reclamation Cost Estimator. We call it STRC as an acronym. And this software does a very robust job of calculating very detailed reclamation cost estimates for proposed projects. And those of us who are, part of the Nevada mining industry are really proud of that software because it is recognized globally as the gold standard for how to determine the reclamation cost requirements for a mining project. And NDEP is consulted frequently by other state mining regulatory agencies and worldwide by regulatory agencies in foreign countries about how to build an environmental regulatory program for mining and how to implement a robust financial assurance program. So we are really the leaders in developing that, and we do an excellent job of it here. So projects on federal land require BLM or the Forest Service to prepare what we call a NEPA document, a document that's required under the National Environmental Policy Act, which means that that agency has to develop either an environmental assessment or an environmental impact statement before surface disturbing activities can occur in either exploration or mine development sites. And a NEPA document is a very involved document to prepare because it requires the agencies to evaluate all aspects of the environment that may be affected by a project. And I've listed the kinds of baseline studies that are required to go into either an EA or an EIS. And you can see they are nearly from A to Z. And I won't read through this, but you can kind of look and see that it's a very comprehensive analysis. And companies have to pay for third-party experts to do all of that baseline work in their project areas that the agencies then evaluate for their completeness, to then put together the environmental assessment or the environmental impact statement to disclose to the public the potential environmental impacts that would result from a proposed project, how those impacts will be minimized and how they will be mitigated. And that whole process, the NEPA process, is the heart of it is public involvement. So many of you have probably seen public notices that get published in the Federal Register requesting comments for scoping for the preparation of one of these documents, or comments that you have on a draft EA or a draft environmental impact statement. And those public comments have play a big role in helping the agencies evaluate the environmental impacts and the range of mitigation measures that should be used, the alternatives that should be evaluated for a project, and they're a really excellent source of information about Nevada's mining projects. They cost companies a lot of money. The BLM or the Forest Service prepares the document. So it's not a company document, it's an agency document. But the companies basically have to subsidize the cost of it. And for an EIS for a mining project, you are looking at a multi-million-dollar document. Okay, next. So Congress has determined that permitting impedes mineral development on federal lands. And that is certainly true of all kinds of minerals, but particularly critical minerals. So we heard today, this morning, we heard about the Infrastructure and Investment and Jobs Act, or sometimes that's called the Bipartisan Infrastructure Law. Section 40206 of that act has a section on critical minerals in it. And it has a couple of very important findings. First of all, Congress has recognized that critical minerals are fundamental to the economy, competitiveness, and security of the United States. That many critical minerals are only economic to recover when they are combined with a host mineral. So that means that a lithium deposit might contain boron or magnesium sulfate, or a gold deposit might contain antimony, or a copper deposit might contain rhenium. And those smaller metals, the byproducts, aren't economic to produce on their own, but they can be produced economically with production of the host mineral. Congress has said to the maximum extent, critical mineral needs should be satisfied by minerals responsibly produced and recycled in the US. So that's really a driver for increasing domestic production of critical minerals. And finally, Congress has said the federal permitting process has been identified as an impediment to mineral production and US mineral security. And in fact, they directed the Department of the Interior and the Department of Agriculture to prepare a report to discuss how that permitting process can be streamlined. And we're still waiting for that report to come out. It was supposed to come out on November 15th, 2022, which was the anniversary of the enactment of this law, but it hasn't come out yet. We understand it should be published in the next couple of months. Okay. All right, and then finally, I just want to talk a little bit about some of the constraints that we face in exploring for minerals on public lands here. So there are roughly 650 million acres of public lands in the US, and about 2/3 of that is already off limits to mining with some kind of restriction on mining. And we said a minute ago, or I showed on an earlier slide, that about 27% of the federal lands here in Nevada are already off limits to mineral exploration and development. There are some other proposals that are in the works right now that federal agencies are considering that would actually increase the amount of land withdrawn in Nevada. There's the Biden administration's initiative to conserve 30% of the nation's lands and water by 2030. And that's would protect over 720 million acres of land and water from development by 2030. BLM is evaluating whether or not to withdraw about 10 million acres in the western US for sage-grouse habitat protection. And in Nevada, the footprint of that proposed withdrawal is 2.8 million acres, and it's in northern Nevada. It would affect mainly northern Humboldt and northern Elko counties. And then there's sort of a perennial debate in the Congress about some fairly radical changes to the US mining law. That's the law that governs how you can all go out and locate claims, mining claims on lands that are open to location. And there are factions within the Congress that want to make that much easier, much more difficult to use, and to constrain the ability to explore for minerals and develop them on public lands. But it's really critical that lands remain open to mineral exploration and development, because the way the system works right now, if you have an idea of where you might be able to find copper or lithium or any other mineral, you have the ability, if you're a US citizen, to go out and locate a claim. And it's called a system of self-initiation. And it's a very, very effective system because it means you put in your time and your money and your intellectual capital to evaluate a spot that you think is favorable for the development, exploration and development of mining. So it basically leverages the private sector investment into public lands that can potentially become a mine that's going to produce important minerals and employ people. So with that, I think I will conclude, but I really appreciate the opportunity to talk to you, and maybe at the end we'll have some time for questions. Thank you.
Okay, let me introduce Tim Crowley. He's the Vice President of Government and Community Relations for Lithium Americas Corporation. Tim previously served 6 years as President of the Nevada Mining Association and 4 years as the association's Government Affairs Director. His government relations experience is rooted to working on Capitol Hill as a legislative aide for U.S. Senator Harry Reid, followed by serving as a senior member of Nevada Governor Bob Miller's administration. Tom also co-founded 2 public affairs companies, Crowley and Ferrado. Oh, let's see.
Yep.
Ferrado Public Affairs and the
Yep.
Griffin Crowley Group.
Yep.
So Tim's going to talk about the Thacker Pass project. Thanks,
Yep.
Tim.
Thank you, Mike and Caleb. I appreciate it. I wasn't sure if I should do slides or if I should just tell you about our project, and I just decided I'm going to do 2 slides, not counting this one. But I have 23 of them in this deck, so we can get deeper if you want to, but I think I'm going to just keep it very high level and tell you who we are, why we're here, what we're building. As Mike said, I'm with a company called Lithium Americas, which is also Lithium Nevada here in the state of Nevada, and we're building the Thacker Pass project. Go ahead, Caleb. I just want to start by just highlighting the demand for lithium, and it's a topic that, do you have the same chart in your?
That's great.
Yeah, all right. Yes. Well, it is a chart that
Must be right
merits reviewing a couple of times, and Mike had it in his slide deck. This one shows supply and demand juxtaposed against each other, and what you see is supply in the bottom in this checkered kind of a area are probable, likely projects. So my project, the Thacker Pass project, Ioneer's project, Graham's project, we're all in this area, which is great. But as supply goes, to meet all of the things we talked about this morning, all of the transportation needs, electrification of our economy, we got to have that. If we're going to fight climate change, if we're going to bring down carbon reduction, lithium is, I'd like to say, the most essential component to make that happen. That's maybe a little hyperbolic, but it's exceptionally important in us getting there. It's not the only thing to get us there, but it's really one of the most important. Well, we're going to hit a gap here, and we're not, and that gap isn't that far away. I mean, theoretically, we're hitting it right around now if we don't get these projects like ours going. And what happens when you have this supply gap? One, you don't meet all the goals that we established this morning that are necessary for a green economy. But 2, if you're going to find U.S. companies clawing at supply, and some people are going to come out short. And so we're in a position today where, as Mike mentioned, 1% of the mineral comes from the United States. But we're huge in the United States, huge consumers of electric vehicles, and that's going up. So then we become dependent on other countries to give us the things we need. That used to be something you could take for granted, much more than you can now. The world has become much less flat than it was now that we've gone through COVID, and the Ukrainian war has really said, oh my goodness, the ability to move commerce around the world freely is starting to become less dependable. So to the wisdom of our administration, to our Congress, they said, let's onshore this stuff. Let's bring it back. Not only do we secure our future, secure our national security, we also can be leaders in the fight against climate change, and we can assure that it's done in the regulatory regime that Debbie just outlined in her presentation, and we can ensure that we're not getting materials that have suspect labor laws. We know that we do it right in the United States because we have the laws that ensure that. So just before we go to my second and last slide, I want to point out that our company is a lithium miner. We're known as a miner, but we're way more than that because we're really a rather sophisticated chemical manufacturer. So that what happens before you get your Rivian charged up is you have to get the mineral out of the ground. And today, most of that comes from Australia or it comes from South America. And once you get it out of the ground, you have to get it into some kind of a solution or perhaps a chemical like we'll make called lithium carbonate. But in either case, that solution or carbonate will most often go off to another country to be processed into a cathode and then battery cells. And where it goes in most cases is Asia and in fact China. And then it needs to go into battery packs, and that could go anywhere on the world, on the planet, but oftentimes it's again in Asia, and Korea and Japan are world leaders in battery pack. We're coming on strong. We've got the Tesla Panasonic Gigafactory just down the road. But the materials you need before they get into the cars that we're driving or gonna drive can go around the world a couple of times. So in the effort to bring down carbon emissions, we're actually putting out a lot of carbon. We're burning a lot of carbon just to get it there. Onshoring makes all the sense in the world for so many reasons. So let's go to my last slide.
Where would recycling fall into that?
Recycling is projected to come in at about 20% of our supply by 2050. It's a ways away. It's an essential component of what we're going to do. But we got to bring it on at some point. Will be like lead acid batteries, where there's not a lot of lead mining going on anymore because we have the materials we need to keep it going. We're going to get there, but we're decades away. Decades away. So I just want to give you an idea of we're building this mine, but we're also building a lithium carbonate manufacturing plant. All of it will be co-located at a place called Thacker Pass. Thacker Pass is located, here's the state of Nevada, up in the very north part of the state. And so if you head to Winnemucca on I-80, hang a left, head up 95 to the town of Orvada. At the Sawtooth gas station, take a left, go 12 miles, and this footprint, this line right here, that's our footprint for our project. So we're near the, I know I'm standing in the light, I'm sorry about that, but we're near the Oregon border. And another really cool thing to look on this map is why are we there? Why aren't we right here? And the reason why is that this dotted line right here delineates an old caldera rim that was formed when a supervolcano exploded 16 million years ago. The same volcanic activity, the same hotspot that created that volcano is the same hotspot that's under Yellowstone today. So if you want to invest in lithium, you might go and try to buy some land in Yellowstone, sit on it for about 16 million years, and man, you'd be in the money, I guarantee it. So that volcano brought a lot of minerals to the surface. They settled and deposited in this old lake bed. Since then, two mountains have pushed up, the Montana Mountains to the north of us and the Double H Mountains to the south of us. And there's huge mineralization in that whole area. It's shallow, it's soft because it was deposited there, and it's a very fortunate place to be in the lithium mining business. The reason that we knew it was there, or we know it's there, is because Chevron was looking for uranium in that area. I've always said the 60s, but I think I'm off by, I think it was more in the 80s. And they found lithium. And so we've since acquired that spot. So we're going to mine it. We're going to do a surface mine. It's simple. We're going to scoop it out, no blasting because it's soft clay. We're going to take it to the rim of that pit. And we're going to separate the sand and gravel in what we've scooped out. It doesn't have any lithium in it. The clays that stay are going to get processed. The sand and gravel, most of it will go back into the pit, and we'll backfill our pit as we go. The clays will be turned into a slurry, sent to a plant that's a couple miles away from there. We're going to leach it, and then we'll and make a solution, and that solution will go through a crystallization process, and we'll drop out all of the other things that are bound to that lithium, and that includes magnesium and potassium and some other things. We got to get it out of there because for a battery to function well, it has to be high purity. And so what we'll end up with is a very high purity battery grade lithium. That'll all happen in that little area. So
Is that potassium? Could that go to LFP batteries?
what do you think, Professor?
Well, that's a lithium phosphorus. It's not potassium, it's phosphorus.
Oh, it's phosphorus, I'm sorry.
Yeah, that would-
Well,
that would be different.
That's, I'm so glad you're here. There are some potential uses for some of the other things we're dropping out of that, and we are working with some very smart people, one of them sitting right there, to figure out how do we market those things. But our business is lithium, and we're focused on doing lithium. We're well on our way. We've been at this thing for over 10 years, going through all the analysis and the NEPA process that Debbie outlined. We're through it. We got our record of decision, which is the approval. It's the conclusion of a successful EIS, and that's when the federal government says, yes, you're free to go. Now that's been challenged in court, but today we could move forward. We have all of our state permits. It used to say all permits to commence construction, or it still says that, but that's because we were missing one more water permit. We got it yesterday, so I got to reword that to say we got all our state permits. They're all there. The big news, and Caleb mentioned this at lunch, is that we partnered with General Motors. That announcement was made on Wednesday, and they're now our largest shareholder. They're going to put $650 million into our company. In return for that $650 million, they will purchase all of our offtake. So it's a big sigh of relief for us. We're secure in our financing, and we're moving forward with our financing, and we know where 100% of our product will go. There's concern that these projects will end up with product going all over the world like it does today. We're committed to making sure that what we produce stays in domestic, not the United States. Domestic includes Canada. I was going to make a joke about being conceived in Canada, but I won't. So I like Canada, and it's a great place. So General Motors is tied to us, and they're our biggest shareholder. All of our product will stay domestically consumed. We're about to start on construction. We've finished all of the cultural analyses that needs to be done for us to move forward. We're fully permitted. We're building up our financing. We're ready to go. Ready to go so much so that we've hired a construction company to build this thing. It's a company called Bechtel, one of the largest, most reputable, safest, most environmentally conscientious companies on the planet. They are a global construction company. They started with projects like the Hoover Dam and have grown from there. We've been working with the communities, in particular the local tribe, and Maria Anderson is here. She's my colleague who works directly with the Fort McDermott tribe. I should also point out that Ashley Madden is in the back and is a colleague that works with me and Maria, and the three of us work very, very hard on community outreach and engagement. It's not tokenism. This is where we're going to live for the next 40, 50, 60 plus years. So these are our families. We have a community benefits agreement where we went to the tribe and said, well, what is it that you need to be successful? If we're going to be your neighbor, what are the things that you need to ensure that you can benefit from our project, get the jobs that you want, and succeed? One of the main things they said is we have issues with childcare. We need a daycare center, preschool, and we're building one for them. It's in a bigger building that's a community center, beautifully designed complex. We're gonna do that on the reservation. We also working with the town of Orvada, where the turn is to our project. We've asked that community, well, what are the things you need? They said, we need you to move. We can't have all of your truck traffic going by our elementary school, which is right on that intersection. It's a K-8 school, and it's beat up. And so we're moving it. We're building a brand new K-8 school. It's going to have things like a new detached gym. They have no gym today. It's going to have a cafeteria for hot food. They have no cafeteria today. It's going to have a lab, which they don't have today. It's going to have a library. They don't have that today. It's going to be a modern school where kids can get a very good education. It'll be away from that intersection, and we're delighted to do that. So community, yeah, thank you. We just put out with the announcement of the GM announcement on Wednesday, a new feasibility study that's available to everybody. If you want to go online, you can see our new feasibility study. We've upgraded, or we've upped our projection on output. We started with a mine in phase 1 that would be 30,000 tons of material per year. And just to put that in perspective, the one operation that's going in the state of Nevada does 5,000 tons per year. So that's not to belittle them, but we're taking that up. And so our first phase now is going to be 40,000. We've gone from 30 to 40 by realizing efficiencies, by studying, by running test after test. How can we get more efficient at our process without adding energy, without adding water, without adding new reagents? And we did it. We went from 30 to 40 in phase 1 by getting more efficient and blending the clays in a way that helps our recovery. This is just phase 1. We're going to double to 80,000. So 80,000 is 16 times more than what the U.S. produces today. Where we've done all this analyses and the tests and the routine or the tweaking of our processes at what's called the Lithium Technical Development Center. It's here in Reno by the airport. If you want to see how we're doing it in a very, very small scale way, our doors are open. We're happy to show it to you. It's a beautiful facility. Just give me a call. We're also doing a carbon footprint. We think that it makes sense. It's an obligation on all of our part. If we're going to be in the carbon business of putting lithium out there to bring down carbon footprint, that our carbon footprint also needs to be low. We're striving to be carbon neutral. We're going to get there. We're going to get a long way there by capturing heat in our process and generating 45 megawatts of carbon-free power in phase 1. When we go to phase 2, we're going to generate 90 megawatts of carbon-free power. That's a huge boost in helping us move towards carbon neutrality. It's not going to get us all the way there. We're going to have to do things like make sure our rolling stock is electric, maybe put in some renewable energy, and then just look at our footprint and everything we do and try to do it as low carbon as we possibly can. And then lastly, we need one more piece to finish up our financing, and we're working very hard on that, and that's pursuing a loan from the Department of Energy. And that we're going through due diligence with that. With that, and there are a lot more slides if you want to dig into any specific issue. Maybe I'll just leave it. Questions are later, right? Okay. I'll turn it over to Graham. Thank you.
Thanks, Tim.
Thank you.
So next we have Graham Ballachey. He's a mechanical engineer with a physics and chemistry background and 13 years of experience within a variety of industries, including combustion research, manufacturing, energy optimization, buildings design, project management, construction management, process development, product development. I'm taking up your time, huh? Graham holds a BS in physics from the University of Victoria and an MS in mechanical engineering from Carleton University. Thanks, Graham.
All right. All right. So my name is Graham Ballachey, VP Engineering with Tonopah Lithium Core. We're an American lithium company. Now that's not to be confused with Lithium Americas, which happens quite a bit. I wasn't around when the company was named, and it's led to some confusion at the time. But American Lithium is the parent company. Here in Nevada, we operate under Tonopah Lithium Core. And I'm going to talk to you today about the company as a whole, and also focusing on the Tonopah project that we have for lithium. Okay, we'll do two. Keep going. This shouldn't be any. Here we go.
I had those slides.
I could have queued it up a little better. So here's where our companies operate. Obviously, we have the TLC project here in Nevada. This is just outside of Tonopah, Nevada. It stands for the Tonopah Lithium Claims Project. Tonopah, for those who don't know, is in between Reno and Las Vegas on Highway 95, I believe. We also have some projects in Peru. The Falciani project is a fairly unique hard rock project down in Peru. And we have a uranium project as well that we're about to spin out into its own company. Between the two, we're going to be focusing on lithium. So between the two lithium projects, we have a large resource base. For those who understand the resources, measured and indicated is the highest confidence level of a resource. And we've got 9.8 million tons of what could be lithium carbonate and another just over 5 million in inferred. It's a large resource base combined. And beyond that, we have a strong focus on ESG, decent treasury, and we have an accomplished management team. This is our management team. These are people that have done this before. So we know how, our team knows how to take early stage properties, explore for whatever mineral we're looking for, and take them through development. So we can go to the next slide. We're a company that likes to find early stage projects and really deliver value through aggressive exploration and development. So in Peru, we have the Falciani project here, and we're planning, we have a resource there already, and we're planning infill expansion drilling, and we have some environmental work happening as well. And we already have what's known as a preliminary economic assessment, a PEA, from 2020, and we're looking to update that to include potassium sulfate and cesium byproducts. But focusing on Nevada, here we are at the Tonopah Lithium Claims. This was from last year when we were drilling out. We were drilling based on our plan of operations, which I'll explain in a moment. You can see this is a large desert environment that's sparsely vegetated, and it's got a very shallow, low-lying lithium claystone mineralization. It's different than that at Thacker Pass, and we think its origins are different, but at the end of the day, it's a claystone type mineral, similar to Thacker Pass, that contains lithium. Our plans right now, we have ongoing metallurgical work to finalize our flow sheet. This was discovered after Thacker Pass, so we're trying to figure out, and they're all a little different, these projects in Nevada. So we have to figure out exactly what's going to work best for us. We also got a plan of operations through the BLM. This is BLM managed land, like Debbie was talking about. And that led to us having quite a bit more drilling that we were allowed to do. So we were able to take our original resource from a few years ago and expand it last year with a whole bunch of extra drilling. We have water rights secured. Last year we bought a second, so we have 2 ranches now that we operate just outside of Tonopah. And we bought them because they have agricultural water rights. And we're planning to continue to operate those ranches as alfalfa ranches and use best practices there until we're ready to convert those over to mining water rights when we're ready. Otherwise, we're going to pull out some more metallurgical sample and move towards a pilot plant later this year. And we got some basic geology that we want to figure out as well. So here's a better look. This is about 6 miles northwest of Tonopah, Nevada. We have this large land area here, which is just over 12,500 acres. It's large. This here in the pink and purple contours, the inside is our measured resource. And then our indicated resource is a bit further out. And that lowest confidence level, the inferred resource, goes a little further than that. And we have explored other parts up here in the north and on the east, but we're really concentrating here in this measured resource area here. And again, this is all from, a lot of this drilling is from our plan of operations that holds us to a really high standard of environmentally and culturally in our exploration program, which was administered through the BLM. So we have that large resource, we got water rights secured, and this is our plan of operations boundary, which I'm not showing on this map, but it does fit into about here. It's a small subsection of the total property is where we have this plan of operations. And to get that plan of operations, we did have to do a lot of cultural and environmental surveying, and no real identified sensitive issues came up. So we are confident that this will be a project that will be able to be permitted. And just some recent drilling results, we're averaging in some of our best holes at about over 1,000 parts per million. One of them is averaging 1,348 parts per million over 60 meters. And we get a maximum of about 3,000 parts per million. But we average more like 1,000 over the entire resource, maybe a bit lower than that. Here's another photo. I just like this one. This is from a few years ago. It shows what the Tonopah lithium claims look like and why there's potentially no real environmental issues out here. Is that this is land that nobody was really using, is the truth. And there's a shallow lithium mineralization here, so it could be the perfect combination. Yeah. So to talk a little bit more about some of the metallurgical work we've been doing, that's lithium carbonate. And that was produced just outside Reno in, we're calling it Reno here, but really it's Sparks, Nevada. I've learned that there's a big difference. At McClelland Laboratories. And we're using a pretty typical, we're an earlier stage company, so we've looked to our big brothers, and we're going with the sulfuric acid leaching as well. And if you go through that typical process, we were able to get, I'll go back for a second. Thank you. There you go. So when it comes to the actual amount of lithium in the mineral itself, through sulfuric acid leaching, we've had tests as high as, that's not what we always get, but we have had tests where we get to 97.7% of the lithium into solution. And then the process you go through is impurity removal and then eventually precipitating the lithium carbonate. And during that impurity removal, you do lose a little bit of lithium. It's kind of unavoidable. So overall, we get 88.1% of the lithium from the minerals as actually the final product. And that final product, the best we've done, that's actually not the best, but this is the one we got in this particular run, is 99.4%, which shows that it's a high purity lithium carbonate. It's not what would be considered battery grade, but we know it's a high enough percentage that we can easily upgrade that if that's what our customers want. Again, this happened just outside of Reno, Nevada. We had the lithium carbonate measured at SGS Lakefield in Ontario. We have similar work going on at a larger scale at ANSTO in Australia. That might be a little ironic, but they know their lithium from the hard rock projects out there. And otherwise, so this data was all put into the recent preliminary economic assessment, which we just announced yesterday, and we're going to file a bit later this in March. And then some of the highlights are on the next slide. So for those who understand these type of thing, I'll explain it briefly. We are assuming that we're going to sell the lithium carbonate for about $20,000 a ton. As we saw, the price has gone as high as over $70,000 a ton. But over the long term, with a lot of extra projects coming online, you can't assume it's going to stay at $70,000 forever. So we decided to be conservative and we went with $20,000. You can make an argument for a bit higher, but that's what we wanted to choose. And we've got two different cases here that we're looking at. One where the only thing we're selling is lithium carbonate. We do have a major potential byproduct though, which is magnesium sulfate, which is used as a fertilizer, and Glenn Miller here, a professor, was telling me about a bunch of other potential end uses for it. So if you make the assumption that we're going to sell that at a conservative price as well, it takes our net present value from $3.26 billion, which is strong as it is, to over $5 billion. And the internal rate of return starts at 27, goes to 36%. The lithium carbonate produced over what right now is a proposed 40-year mine life. It could be longer, but for this PEA, we decided to keep it at to some of the higher grade material. It's going to be 1.46 million tons of lithium carbonate produced. So that works out to, on average, about 38,157 tons per year. So it's not as big as what they're proposing in Winnemucca, but we could scale this up and down potentially, and we decided to be conservative for our first kind of kick at the can here. CapExes are, to build this thing, this is going to be a phased project similar to Thacker Pass, start at a certain level of production and then jump. So we start at 24,000, we jump to 48,000, and then towards the mine life, it kind of peters off. Phase one, we're looking at 819 million, and then we add another 600 and change, and we get to 1.4 billion. And if you're interested in how much it costs to produce a ton of lithium carbonate, in our PEA, we're showing that we're able to produce it on average for $7,443 per ton of lithium carbonate, and we're going to try to sell it at 20,000. If you include magnesium byproduct credits against that operational expense, it gets down to something that looks kind of ridiculous, which is 817, which shows that lithium alone is a very strong project. If we can include any byproducts, and same with your project as well, it just only gets better. Like I said before, we're a company that's committed to environmental, social, and governance values. We're trying to be as responsible as we can with the environment. We think we're really well located to be responsible with the environment. It's a place with no sensitive issues identified so far. We have a lot of social commitments. We're early outreach to the indigenous people, both in Nevada and in Peru as well. We have good relationships with the local communities, and we're committed to health and safety best practices. So this is very specific to Nevada. This is Governor Lombardo talking about the lithium produced. We really think it can help Nevada become, in combination with the other projects that are being developed here, Nevada, the nation's lithium supply chain powerhouse. So Governor Lombardo back in 2023 said, whether it's closing the lithium loop, unlocking innovation and investment in logistics, entertainment, science and technology, or embracing entrepreneurship, the message is that Nevada is ready to partner. The previous governor, Governor Sisolak, said lithium is the primary ingredient in energy storage, and Nevada is home to the most successful lithium reserves in North America. And, so if we talk about no known sensible or environmental or cultural issues, and this can actually produce a lot of jobs, we think, for at least 40 years, and there's a lot of lithium left after 40 years. We think that the TLC project represents an exceptional opportunity to help make Nevada the primary lithium producing state and to achieve significant synergies with other Nevada battery supply chain companies. And again, this is stuff people have been talking about all day long. The Biden administration, they have a lot of critical minerals and environmental initiatives, and we think that TLC's favorable location, metallurgy, and environmental setting are an excellent place to develop a large domestic lithium resource. Again, we've been talking about this all day long already. The United States does do a little mining, but when it comes to the chemical process and battery production, it's really not that much at all right now. So our company likes to hang out in these first two stages, the extraction and mining and the chemical processing, and we're hoping to get that bar to tick up a little bit. So that's it. That's an introduction to Tonopah Lithium Corps, which is an American lithium company. And yeah, thanks for listening, and I'm hoping to answer any questions you might have.